Hello dear students, welcome to Carbon. So let's have a moment of chemistry with my YouTube channel, Carbon. So let's start it. Yeah, so today we are going to study about significant figures. What are the significant figures and why we are studying it? Okay, yes, this is a number used to express precision in measurement. Okay, so in lab we are doing lots of experiments and we will get a set of result or set of measurements. In those measurements we need precision or we need accuracy, we need a clarity from those set of experimental results or experimental measurement. So we are using significant figures to express precision in such measurements and which indicates accuracy in those results. Okay, so in this video, we are going through how can we identify significant figures in those digits or those results, and let's go through some textbook exercises for more clarification. Okay, how can we identify significant figures? So the first rule is non-zero digits are always significant. Non-zero digits. So here the example is 123. It's a non-zero digit, right? There is no zeros. And these three numbers are significant. 123, like 4, 9, 8. These are non-zero digits. So here also significant figure is 3. I hope it's clear. It's very simple, right? Then second rule is leading zeros are not significant. Leading zeros are not significant. Leading means the zeros just come before the non-zero number. Here 4, 5 are the non-zero digits and 3 zeros are leading with a decimal point. Okay, so we can't count it. It's not significant. So here the significant figures are just 2, 0.00321. So what's the significant figure here? Just 3, because we can't count these 3 zeros, 3 leading zeros. That is the second rule. Get it? Non-zero digits are always significant. That's the first rule. Second one, leading zeros doesn't count. Leading zeros are not significant. Then third one, captive zeros. What does it mean by the term captive? Captive mean zeros between non-zero digits are always significant. So here 1002. These two zeros in between two non-zero digits and these captive zeros always count, and here four significant figures are there. So another example like 5.001. 5.001 with a decimal point. So this is captive zeros. We can count it. Get it? So here the significant figure 1, 2, 3, 4. Significant figures are 4. Clear? So let's move to the fourth rule, trailing zeros in a decimal number. Trailing zeros. Zeros come after the non-zero digits are always significant. So here 3.00 has three significant figures. So it's in case of decimal number, right? There was a story about trailing zeros in a whole number without decimal point. We can't specify it. So look at this example, 1500, right? 1500, 1500 may have two, three, or four significant figures, because these 1, 5 are non-zero digits. That's always significant, and these zeros which just coming after the non-zero digits maybe count. Get it? So 1, 5, 0, 0, 2, 3, or 4 significant figures are there. So these are 5 rules regarding significant figures. I hope it's clear. Okay, so let's move to a textbook exercise. So we need to round up the following uh, digits up to 3 significant figures. So the first one, 34.216. So we need to round up this to 3 significant figures. How can we round up this to 3 significant figures? We need to round this. Okay, so here 34.216, and the digits coming after this 2 is less than 5. So we can write this 34.2 because it's 1 here. because it's less than 5. Get it? The another one, 10.4107. Okay, so we need to count up the maximum 3 significant figures. So okay, so that's our duty. 10.4. So when I'm writing 10, it's 2 significant figure here. Then 10.4, because the next number is 1. If it is 6, if it's greater than 5, we can count it as 10.5. Clear? So when we are doing another exercise, we will get more clarity. Then another one, 0.04597. Okay, how can we write this? 0.0 leading zeros. It's about the story of leading zeros, right? Leading zeros, does it count? Remember, 0.0460. So we need to add a trailing zero here, because these two zeros doesn't count. These three numbers, 460, that is 3 significant figures. Okay, then another one, 2808. Okay, it's a non-zero digit, so we can write this like 2810. Clear? It's very simple, right? Okay. So if you have any doubt in the rules, you just go through the back and just re-watch the videos regarding the rules to find significant figures in digits. Then next question is, how many significant figures are present in the following? So the first one, 0.0025. This is a digit and we need to count how many significant figures are there in this particular number. Okay, so you just go through the rules again. Here the leading zeros are there, right? So leading zeros doesn't count. Leading zeros doesn't count. So the significant figures, how many significant figures are there? It's 2. Okay, then second one, 208. It's a captive zero, right? Zero in between non-zero digits are called captive zeros. Captive zeros. So it's 3. Get it? Then third one, 5005. Here again, captive zeros in between non-zero digits. That is 1, 2, 3, 4. Then fourth one, 126. 3 zeros are there. 3 trailing zeros. So we can't specify it, right? You remember the rule. 1, 2, 6. These three numbers are significant, but the zeros without decimal. So we can't specify whether it is 3 or 4 or 5 or 6. But 3 is sure. 3 is significant. So you can write 3 there. Then it comes to next 500 with 0. So here it's 4 with a decimal number, right? Then another one, sixth one, 2.0034. What's the story here? It's a captive zero with decimal point. So 2.0034. 1, 2, 3, 4, 5. So here the significant figure is 5. I hope it's clear. And do more practice question regarding the same, and watch the rules again and again when you have any confusions or doubt. Okay, students, I hope it's clear for you. Thank you so much and bye bye.